All right, so we're going to go through the semester review. Looking at question 1, it's asking you to do a limit. So if you remember back to the beginning, we looked at where you're taking the limit. So if you're doing the limit at 3, the first thing you're going to try to do is do substitution. So the limit as x goes to 3 would be 9 minus 9 over 9 minus 15 plus 6. So we actually get undefined because there's 0 at the bottom of the fraction, so it's undefined. What that means is you have to attempt something else. And the best thing for this problem to do would be to try to factor it. It is factorable. Numerator, the denominator, be minus 3 and minus 2. And so because that simplifies, we are now going to simplify this to x plus 3 over x minus 2. And we're going to take the limit as x goes to 3. So once it's completely simplified, then we can attempt to put in the value of positive 3. When you put in the value of positive 3, you get 6 in the numerator. 3 minus 2 is 1, so the answer to letter A is 6. Number 2, or letter B, this was one that had a special rule. The limit as x goes to 0 of x over sine of x is equal to 1, and so is the limit as x goes to 0 of sine of x over x. So in this problem, it's very similar. So what we're going to do is we're going to break this apart. It's 5 times x and then 3 times sine of x, and so we are going to break up the fraction into a product, which is the same exact thing as the original problem, but in doing that, it makes it a little bit easier for you to see that you're actually taking the limit as x goes to 0 of x over sine of x, and then you're going to multiply it by the limit as x goes to 0 of the constant 5/3. Now, you can break apart functions by multiplication and then take the limit of each piece. So in this case, we know the limit is 1. In this case, 5/3 is a constant function. So it literally, at 5/3, is a function that does this. So the limit as x goes to 0 would be this point right here, which is itself. So really, you end up with 5/3 again. The limit to any value of a constant is always itself. So the answer to letter B would be 5/3. Letter C, in this case, looks very similar to A, but now you're going to be doing as x goes to infinity. And this is one where we would be looking at end behavior and not a specific value. So 1A, we took the limit as x goes to 3. Here we're going to be taking an end behavior. So end behavior is nice because you can circle the highest power in the numerator, the highest power in the denominator, and then simplify. You get negative 1/2. Therefore, in this case, because it's simplified completely, that actually will be our limit, negative 1/2. Letter D, same concept. The limit is to infinity, so we're looking at end behavior again. Same thing, we're going to circle the highest powered term in the numerator and in the denominator, so I get 5x cubed over x, which simplifies to 5x squared. So how do you know what the actual limit is as x goes to infinity? You would graph essentially what it looks like. So 5x squared would be a parabola facing up at the origin. And so this arrow here shows us the limit as x goes to positive infinity of the function. And this arrow here shows us the limit as x goes to negative infinity of the function. And the question in this case was to positive infinity, so the arrow points towards the sky, which means that the function goes towards infinity. Let's see, letter E, again, end behavior. Circle the highest power term in the numerator, highest power term in the denominator. This one is extremely easy because if you think about infinity being substituted in, you're really going to end up with having the denominator get huge. So if I follow the same steps we did before, you would end up with 1 over 3x cubed. And you want to think about the rule of really large numbers. If you substitute infinity into the numerator, but infinity into the denominator, but the numerator stays 1, you end up with something that looks like this. Well, the bottom becomes extra, extra huge, so you're dividing by a huge number. and so the value is 0. The easier way to do this problem would be to remember the rule. And the rule is when you take the limit as x goes to infinity, positive or negative infinity, and you have a function on top that's polynomial and a function on bottom that's polynomial, if g of x power is greater than limit as x goes to positive or negative infinity of the function f of x over g of x will be 0. And if you remember back to when you guys did horizontal asymptotes, the horizontal asymptote for that function would also be y equal to 0. The limit essentially follows the pattern of the horizontal asymptote. Letter F. So we did this one in class. We talked about the fact that this looks very similar to, let's see, wrong definition. It looks very similar to f of a plus h minus f of a all over h. And so what you're really looking at is the derivative of f at a. So if you go back to the original, so here's where I start. I start by looking for where that h is. And then the value that's right next to h is your a value. And then the next thing I do is I replace this whole thing that had the a plus h with an x. And that tells you what the function is. The function is sine of x. So the question that they're asking you is to find the derivative at pi over 6. It's a completely different way to do the problem, but if they're using that definition, might as well use it to simplify the problem a little bit, because you can find the derivative of sine of x easily. That's cosine of x. And then you can find the cosine of pi over 6 easily. And remember, cosine pi over 6, the point would be root 3 over 2, comma 1/2 at pi over 6, and cosine is the x value. So the answer to this question is root 3 over 2. So that notation, limit as h goes to 0, should give you the hint that they might be using the definition of a derivative. Letter G, substitute in 2, we get undefined, so this we're going to attempt to factor. So x plus 4, x minus 2 over x minus 2. Since these cancel, I get that the limit as x goes to 2 of the function is going to be the same as just taking x plus 4, and therefore the answer should be 6. And then letter H. So this is one where you're going to use kind of like the conjugate. So we're going to multiply this by root of x plus root of a over root of x plus root of a. And so the numerator becomes that rule of x minus b times x, or sorry, a minus b plus, or times a plus b, which ends up being a squared with a big minus and then b squared. So in the numerator, you actually get x. Root of x times root of x just gives you x. And then minus root of a times root of a just gives you the a, all over x minus a times the root of x plus the root of a. We can simplify this, and so we get the limit as x goes to a, which I forgot over here, of 1 over the root of x plus the root of a. X is going to change to the root of a, so we get 1 over 2 square root of a. How did I get that? Because if you look at what I have here, I get 1 over root of a plus root of a, which gives you 2 root of a's. All right. Which of the following is continuous at x equal to 1? So easiest way to check for continuity is understanding if the value can even be used in the function. And then I'm going to give you one example of a function where the value can be used. It's part of the domain, but there is a discontinuity. So in letter A, or f of x, if x equals 1, there's a vertical asymptote. So which of the following are continuous? This one is not continuous because of the asymptote at x equal to 1. If I substitute in 1 here, I get 1 minus 1. ln of 0 does not exist, so this one also can't be continuous. And then sine of x over x would be the sine of 1 over 1, which is equal to the sine of 1, which is an actual value, so this one is continuous. Now, where we could really get the problem wrong is if there was an m of x, which is equal to the absolute value of x minus 1. Actually, no. That one would still be undefined. That is not what I was going to do. So the greatest integer function, we haven't touched that probably since chapter 2. And that's the function that looks like the step function, closed circle, open circle, closed circle, open circle. All right, so if you look at the function, you can tell it's not continuous at 1, but if I find m of 1, oh sorry, that's supposed to be a 1, the value is actually 1. So this function is the greatest integer less than or equal to the value that you put into the bracket. So because 1 is an integer, the value becomes itself, but the function is not continuous at x equal to 1. Number 3, find the derivative for each of the functions. So let's do this one here would be a chain rule, so derivative of the outside, leave the inside exactly the same, multiply by the derivative of the inside. This I'm going to rewrite as minus x to the negative 1, so I get plus 9x to the negative 2. And so y prime would be 1 over x plus 9 over x squared, common denominator, so multiply this by x over x, and so we get x plus 9 over x squared. Letter B would be a quotient rule, so y prime is equal to low d of high minus high d of low all over low squared. It does help sometimes to just write out what the derivatives are if you have trouble with the quotient rule, because it's a lot of steps. In this case, I get that my next step would be that y prime equals 3x plus 6 minus 3x plus 4. Please make sure you distribute your negative all over x plus 2 whole thing squared, and we get 10 over x plus 2 squared. Letter C, I can tell that it's going to be a product rule. The product would be between this term and this term. So I wrote down in red the derivative of my two pieces. So y prime would be leave the first term alone, multiply by the derivative of the second term, plus leave the second term alone, multiply by the derivative of the first. We end up that there's a common term, no common terms, so I really end up with almost the same thing again. I'm going to move the negative out, and then I'm going to move the 6x in front of the cosine. Letter D, I'm going to rewrite this to the 1/2 power. So chain rule, derivative of my outside, leave my inside exactly the same, times the derivative of the inside. Therefore, if I want to rewrite this in the numerator, I still have 3x squared. In the denominator, I have that 1/2. The 2 is in the denominator, and then I have the square root of x cubed plus 7, and it cannot be simplified anymore. That would be the derivative. Letter E, I'm going to rewrite the problem as sine of 6x whole thing squared plus x to the 4th. So the derivative would be, take the derivative of the outside, leave the inside exactly the same, multiply by the derivative of this, which is another chain rule. So derivative of the outside, leave the inside exactly the same, multiply by the derivative of the inside. So that was just the derivative of the first term. Now I'm going to do the derivative of the second term, which would be bring the power down, subtract by 1, so positive 1/3 would be the power. Then I'm going to see if I can rewrite this at all to be nicer. So 2 times 6 makes 12, sine of 6x times cosine of 6x, and then plus 4/3 x to the 1/3. Now, that should be the answer. Letter F, taking the derivative, this would be a chain rule. Derivative of the outside, but leave the inside exactly the same as it was, which was g of x, multiplied by the derivative of that inside. So that would be the derivative of f. G would be a product rule, a product between those two. So 2t would be this guy's derivative. So the first derivative would be leave the first term alone, derivative of the second, plus leave the second term alone, derivative of the first, and in this case, I'm going to factor out a t, and I get that when I factor out, I would lose a t here, and I would lose this t here. So I end up with the leftovers of this. All right. Letter H, 3 terms, so I'm just going to take the derivative of each piece. So piece number 1 would be 1 over the square root of 1 minus 3x, whole thing squared, multiplied by the derivative of that inside, which would be 3, plus tangent's derivative is just secant squared x. And then this term here, I'm going to rewrite as negative x to the negative 3. So I would get positive 3x to the negative 4. You won't simplify this one much. It becomes 3 over square root of 1 minus 9x squared plus secant squared x plus 3 over x to the 4th. And if this was multiple choice, that actually would be the answer. You probably would not have to get a common denominator. And letter I. So in this case, I have 2 terms. The derivative of the first, I'm just going to put the 5 on the outside. And then because that was a constant multiple, I get to just do that. I don't have to do the product rule. The derivative of the inside term would be 6x squared. And then plus, I'm going to do the same thing. This 5 can come down. And then I'm going to take the derivative of arctan. Arctan is the same thing as tangent inverse of 2x. So the 5 already is down there. The derivative of tangent inverse would be 1 over 1 plus 2x, whole thing squared. The derivative of the 2x would be 2. So in this case, I end up with 5. I'm actually going to factor the 5 out. So if I factor the 5 out, divide this by 5, divide this by 5. My first term is 6x squared. My second term would be 2 over 1 plus 4x squared. So that is the answer that I'm going to leave with the 5 factored out. If it was multiple choice, there may be a common denominator. You may have to multiply the 5 into the 2 factors, but you would just go and match your answer at this point. So I'm going to stop that video there.